Hey folks, and welcome to our next video from Unit 10 talking about compounds. I got my son Judah here with me today, so if you got a little noise in the background, that's what you know it is. And he's going to be helping us out talking about compounds. So let's get started. So we've talked about compounds before. Compounds are a kind of pure substance where two or more different elements are chemically bound together. And that's pretty easy to see when you look at like formulas or things like that. You're going to have two different elements that are in the formula, or instead of it being the same element, whether that's, hydrogen and oxygen, hydrogen and chlorine, sodium and chlorine. There's lots and lots of different compounds out there, but the main thing is that there's two or more different elements that are chemically bound together. Now, we've talked about the fact that these are chemically bound together before, but we never really defined what that means. So let's get into it and let's talk about what it means for there to be a chemical bond. Chemical bonds are formed when two atoms are basically stuck together. It's how atoms are held together, and they're held together because there are interactions among their valence electrons. And the reason why bonds form is because elements want their outer energy levels to be full. Remember, that's what we were talking about in our last unit, or the last video, where we were talking about how elements want to be stable, right? Atoms want to be stable, and in order to do that, they have to either gain or lose valence electrons. So bonds form because elements are wanting to gain and lose electrons, and they have to have somebody to share or give those electrons to. They have to either take electrons from somebody, or they want to give electrons to another atom. And so that's why bonds form, is that you get these interactions between elements. There are two main types of chemical bonds, covalent and ionic. So let's look at the properties of those. In a covalent bond, the electrons are being shared between atoms. Okay, they form molecular compounds, and they are involving nonmetals only. In contrast, we have ionic bonds. Here, electrons are being transferred from one atom to another. All right, these form ionic compounds, so that's pretty easy to remember. And in this case, they involve metals and nonmetals. So let's take a look at each of these in a little bit more detail, and then we'll go from there. So in a covalent bond, valence electrons are being shared, and that's the really important kind of key word here. They're being shared between atoms to fill their outer energy level. So we take a look at hydrogen, right? Hydrogen has has one valence electron. It wants to have two in its outer energy level, right? Because it's just the first level, which needs two to be full. So what's going to happen is that these hydrogens are each going to share their one electron with each other, so that now they each have two. Chlorine, right, has 7 valence electrons. It needs one more, so each chlorine is going to share one electron with the other, giving you a total of 8 in the outer energy levels. You can also have compounds with more than just two elements. Here we have carbon bonding with 4 hydrogens. Carbon has 4 valence electrons on its own. Each hydrogen has 1, so when you add all that up, that gives you 8 in the outer energy level, and then each of the hydrogens has its 2. Similar idea with the oxygen over here. It has 6 valence electrons. Each of those hydrogens contributes 1 electron to give a total of 8, and now each of the hydrogens has its 2 as well. Now what's happening is that these electrons being shared cause the atoms to be attracted to each other, right? People that you share things with, right? You share meals with family, friends, things like that. You become attracted to them, right? You become closer. That's what's going on here. Now, this only occurs between nonmetals because they all want to gain electrons. If we think back to the last video, right, the oxidation numbers, they all had negative oxidation numbers. That's because they all wanted to gain electrons. So because they all want to gain electrons, they are sharing them so that nobody ever loses an electron. Now let's talk about ionic bonds. Here, valence electrons are transferred from one atom to another in order to fill their outer energy level. Keyword here is transfer. The electron is physically going from one to the other. It's leaving one of them and going to the next. What this does is it creates positive and negative ions, and opposite charges attract, so therefore they are attracted to each other. They want to come together. This occurs between metals and nonmetals because the metals want to get rid of their electrons. They have positive oxidation numbers. They want to get rid of their valence electrons. Nonmetals, we just said, want to gain electrons. So you pair elements that want to get rid of them and elements that want to gain, and so that's how they're able to function well. So what's happening in our example here, we have the sodium. Sodium has 1 valence electron. It's going to get rid of that valence electron and give it to the fluorine. Fluorine has 7 valence electrons, plus the 1 gives it 8. So now its outer energy level is full. Notice the sodium's outer energy level is full. When that occurs, the sodium, because it's losing an electron, becomes positively charged. The fluorine, which is gaining the electron, becomes negative charge. Positive and negative, opposites attract, they come together. That's how your ionic bonds work. Now, the skill that you need to be able to have from this is that you need to be able to identify ionic and molecular compounds just by looking at the formula. Okay? So the question you need to ask is, what is it made of? Well, if it's made up of 2 nonmetals, that's going to give you a molecular compound. If it's made up of a metal and a nonmetal, then that is going to be an ionic compound. Pretty straightforward. Let's do a little bit of practice. Our first example, sodium and chlorine. So you got to look on your periodic table to be able to identify what the names of those are. Then you got to look on your periodic table and figure out, okay, are they metals or nonmetals? Remember, metals are to the left of the staircase. Chlorine is to the right, or nonmetals are to the right of the staircase. So where sodium is on the left side, which means that it is a metal. Then we have chlorine, which is on the right side, making it a nonmetal. We have a metal and a nonmetal, therefore it's an ionic compound. All right, example number 2, we've got hydrogen and oxygen, right? This is water, H2O. Hydrogen is the one exception to our rule about the metals and nonmetals, right? Hydrogen is on the left side of the periodic table, but it is a nonmetal, and you got to make sure that you remember that exception. Oxygen is on the right side of the periodic table. It is also a nonmetal. We've got 2 nonmetals. That means that it's a molecular compound. All right, so you got a little bit of practice today, a little bit of practice tomorrow, and then we're going to talk about how do we actually name these things, right? NaCl, that's sodium chloride. How did we figure that out? How do we know that its name is sodium chloride? All right, so thanks for watching, and I'll see y'all next time.